Hi, in this tutorial we are going to learn how to run a linear regression analysis in Excel and how to interpret the summary output. Regression, as we know, is used to find correlation between two or more variables. In this tutorial we have been given the population and the number of cars in a city, and we need to find the correlation that exists between the two, if any, and then find the number of cars if the population of the city is 240 million. We all know that the regression equation is commonly represented as y is equal to intercept plus coefficient of x into x, where y denotes the dependent variable and x denotes the independent variable. In this example, the population of the city is the independent variable and the number of cars is the dependent variable. That is, the number of cars will be dependent on what the population of the city is. So let us begin the regression analysis. For that, we go to the Data tab and we go to Data Analysis. We select Regression, click on OK. The Y range would be the range of the dependent variable. So in this case, which is the number of cars, so we have selected B5 and B11. Then the input X range will be the independent variable, which in case is the population. We'll check on labels and we want our output to be in the new sheet. For residuals, check on residuals and click on OK. Once this is done, we get a whole summary output with important regression analysis. So in regression statistics, the most important thing that we need to check is R-square. So R-square basically tells us how good the regression fit is. So the closer it is to 1, the better the fit of regression it is. Here the fit is almost 98%, which means that 98% of the variation in the number of cars in the city is explained by the independent variable population. So which means basically that this regression is a good fit. Now another thing that we need to check in the ANOVA table, which is the analysis of the variation table, is the significance F. It basically tells us how reliable the results are. If the significance of F is greater than 0.05, then it's probably better to stop using this set of independent variables and change them with someone else. In this case, since the significance F value is very low, this means that it is okay. And similarly, we need to check the p-values. The p-values should also be less than 0.05 to denote that the regression is proper. Now coming to the coefficients. In our regression equation, which is being defined as y is equal to intercept plus coefficient of x into x, we get our intercept as 39.19255 and the coefficient of x is 0.213665. So basically our regression equation would be y is equal to 39.19255 plus 0.213665 into whatever the value of x is. So this is how our regression equation would look like. And I'm just going to copy this and paste it here. And here I'm going to replace it with 240 to get to know the number of cars. So we know that when the population of the city will be 240 million, the number of cars would be 90.47 million in the city. So this is how the regression equation works. Another thing that we have got here in our summary output is the residuals. So basically what the residuals do is that they show you how far away the actual data points are from the predicted data points. So for example, the first data point here equals 200. So if we replace 240 with 100, we get our answer as 60.55905, whereas the actual number of cars is 60. And once we subtract it, we get the residual value. So as you can see, the residual here is minus 0.55901, which is what we have got. There is another way of doing regression, but in that we do not get the summary output and we don't get any detailed analysis, and that way is by way of trend charts. So what we need to do is we select the data, we go to insert and we select a scatter chart. We go to design, add element, and we go to trend line and we go to more trend line options. So here we'll take a linear trend line and we'll check the box for display equation on chart. You can also display the R squared value, and as you can see, we get the same equation as the equation we have got from our regression analysis. You can see that the intercept is 39.193, which is what we've got here, and the x coefficient is 0.2137, which is exactly what we've got from our regression analysis as well. And we can also verify the value of R square, which is 0.9774, which matches with our number in the trend chart. So these are the two ways in which we can find a regression equation in Excel. I hope you found this tutorial useful. Thanks for watching.